Welcome to the sloped-intercept form of a linear equation. The goals of this video are to graph a line in sloped-intercept form and also to determine the equation of a line in sloped-intercept form. The equation y equals mx plus b is called sloped-intercept form of a line, where m represents the slope of the line, the coefficient of x, and b, the constant on the end, represents the y-intercept 0b. If we take a look at this line, it's in the form of f of x is equal to ax plus b. So in this example, the a is the slope and the b is the y-intercept. Let's change the value of the slope and see how it affects the line. Here we see if the slope is negative, the line slopes down from left to right. And as soon as the slope changes to positive, the line starts to slant up from left to right. So here we have positive slopes and here we have negative slopes. Notice changing the slope does not affect the y-intercept. Now if we keep the slope constant and now change the value of b, or the y-intercept, we'll see that changing b does not change the slant, it just shifts the line up or down because the y-intercept is changing. If the value of b is positive, we have a positive y-intercept. If the value of b is negative, we have a negative x-intercept. Let's see if we can use that information to graph the line y equals negative 1/2 x plus 3. So our slope will be negative 1/2 and our y-intercept will be the point 0.03. So in order to graph a line in sloped-intercept form, there's really two steps. Step 1, plot the y-intercept, so we have 0.3, and find additional points using the slope of negative 1/2. Remember, the slope tells us the change in y over the change in x. So the change in y is negative 1, so we're going to go down 1. The change of x is positive 2, so we'll go right 2. So from the y-intercept, we go down 1, right 2. And we can do that again if we wish, down 1, right 2. Essentially what we have to do now is just connect these 3 points to form a line. Our line would look something like this. Again, we have our y-intercept of positive 3 and our slope of negative 1/2. So we can pick any point on the line. Let's say I pick this point. If I go down 1, right 2, I'm going to find another point on the line. Let's go ahead and try another. Let's identify our slope and our y-intercept. In this case, our slope is 4, but to make use of a slope, it needs to be in fraction form. So we'll write 4 as 4 over 1, and our y-intercept is going to be the point 0, negative 5. Notice we must take the sign with it to identify the y-intercept. So let's go ahead and plot our y-intercept of 0, negative 5. And from the y-intercept, we're going to use the slope to find additional points. So again, the change in y is positive 4. We're going to go up 4. The change of x is positive 1. We're going to go right 1. From here, we go up 4, right 1. We find a point on the line. Again, we can do that again if we wish. Up 4, right 1. And you can see if we connect these 3 points, it will form a line. And it would look like this. Now let's approach this from the other direction. We'll be given information and we want to find the equation of the line. So remember, in order to find the equation of a line in sloped-intercept form, we need to find two things. We need to find the slope and we need to find the y-intercept. So in this problem, we're given the line passes through this point and it has a slope of positive 1. So essentially we've already found half of what we need. We know our slope is equal to 1. Let's go ahead and put that in our equation. Now there's a couple ways of finding the value of b. If this point is on the line, it must satisfy this equation. So what that's telling us we can do is we can replace y with negative 3 and x with negative 2 and solve for b. So when y is negative 3, x must be negative 2, and this gives us an equation with one unknown. Let's go ahead and solve for b. Add 2 to both sides. Looks like our value for b is equal to negative 1. So we just need to go up to this equation here and replace b with -1. So the equation we're going to come up with is y is equal to 1x, of course the 1 is optional, minus 1. Now we're asked to graph this line as well, so let's go ahead and get it started here. We have a y-intercept of -1, and we have a slope of +1. Well, if our slope is +1, the first thing I would do is make it into a fraction. So I know from here I can go up 1, right 1, up 1, right 1, and so on. The line would look like this. We should make sure this line does contain the point -2, -3, and we see that here. So our work is correct. Okay, let's try another. Determine the equation of the line through the points -4, -2, and 2, 1. Again, in order to find the equation in slope-to-intercept form, we need the slope and we need the y-intercept. In this case, we have neither, so what we have to do first is find the slope by using our slope formula. So we'll call these the 1's and we'll call these the 2's. So we'll have y2 minus y1, 1 minus -2, over 2 minus -4. Looks like we're going to have a +3 over a +6, which simplifies to 1/2. We know our slope is equal to 1/2. Let's fill in that information. We still need to find the y-intercept. Since both of these points are on the line, we can select one of these points and sub in the value for x and y and solve for b. Let's go ahead and use this point here. So what that tells us is that when y is equal to 1, x must be 2. Simplifying. Looks like here if we subtract 1 on both sides we'll get a b value of 0. So if our y-intercept is equal to 0, the equation of our line will be y equals 1/2 x. Let's go ahead and plot some points and then sketch our graph. We know our y-intercept is 0. This point is on the line. From here with a slope of 1/2, we would go up 1 and right 2, up 1 and right 2. We would make our line. I've already sketched it on this screen here. So here's our line. Let's just double check that it does contain the points -4, -2 is here, and also the point 2, 1 is here. Our work looks good. Here's one last example. Determine the equation of the line passing through the points 2, -3, and 2, 2. Let's start by finding our slope. y2 minus y1 would be 2 minus -3 over 2 minus 2 over 2 minus 2. Now this slope kind of blows up. We have 5 divided by 0. That's an undefined slope or no slope. So we have a little bit of a problem here. What we might want to do now is at least plot these 2 points and get a better idea of what our line looks like. So we have the point 2, -3, and we have the point 2, 2. Well, if we try to connect these 2 points, we get a vertical line, which is what we should expect because we know if a line has no slope or an undefined slope, it's a vertical line. Now, do you remember how to find the equation of a vertical line? If you take a look at these 2 points, what you'll find is that both x coordinates are equal to 2. And in fact, that is the equation of this line. X must equal 2 for any point on this vertical line. So they all don't work out perfect when you try to use this slope-to-intercept form. So you still have to remember some of the key characteristics of lines, including both horizontal and vertical lines. Okay, thank you for watching. I hope that helps explain how to graph lines in slope-to-intercept form, as well as how to find equations of lines in slope-to-intercept form.